Okay. Start to pick back up here. Going through the chat, looking to see if we've missed anything. I know I saw one comment there about performance of electrolytic cells and other nucleation sites. Do we expect any differences there? Zach, do you have any comments? Zach Hayden. Can anybody hear me?
Yes, this is Ron. I can hear you. What was the question again?
No, I was going to start polling people. Well, the one question was, is the electrolytic, any issues with regards to electrolytic cells? Let's see, where was that? Do we know about the performance of electrolytic cells and other nucleation surfaces in lunar conditions? Shall we expect significant mass transfer issues?
You had presentations earlier today about radiation effects on the moon and solar particle events.
Yeah, this would be more along the lines of whether or not we have issues with regards to, how should I say, bubble accumulation, causing issues that might degrade the performance of, say, a fuel cell that was oriented either vertically or horizontally.
Oh, I see.
In terms of the systems, do we expect problems, or did we have problems with regards to the inclination of the lunar surface? Like, did the rover behave more poorly as it was climbing up a hill or going down a hill, or better on the flats, other than what you would expect?
No, it worked great everywhere. And we designed it in and tested it fully here on Earth and made sure that it was going to operate. The problem we had, though, was dust on the radiators that we couldn't clean off. And even on Apollo 17, we had a mission rule. They were supposed to barbecue the whole assembly, the command module connected up to the lunar module, about the longitudinal axis to balance out the solar heating and the radiation to space. Well, they came out of it. I went up each morning to the headquarters building. I got a telefax. which had the vehicle attitude history for the previous day. I started seeing a trend there that they were coming out of that barbecue mode at the worst possible attitudes for the longest period of time with our bottom of our rover pointed toward the sun. So at least I was able to warn them that, hey, we're going to be hot. We got to the moon, we were only 15 degrees off the upper temperature on one of the batteries. So we had lots of different things happen on the way to the moon and on the moon.
So and that's something definitely that they have to be careful of in terms of, like, say, transit, say to Mars, or.
Oh yes.
Although I'm pretty sure that they're not going to be doing a rotisserie mode on the way to Mars.
No, they don't have to, because they're going so far away from the sun, and that brings up a question. I don't know how they're going to get solar power. Are they going to have flip out big big solar arrays, or what they're going to do for trying to go to Mars? Other thing, on Mars, how are you going to have enough food to keep the crew alive just in the transit getting to the moon, much less staying there for a year?
I know that they've talked about, like, pre-positioning food. I also know that the Kennedy folks have been trying to work on we'll call it a planned habitat, but space farming.
Yeah, this is Jim Bryan. There's a lot of work in how to make sure the nutrients are sufficient, but food is, other than propellant, the largest single mass item going to the moon. We are looking at some in-flight food production, to supplement the prepackaged food, but at least going to Mars and back, the bulk of it will be food. And there's work done on how much of that food needs to be refrigerated and at what temperatures to slow down the decay or the decrease of the micronutrients, vitamin B, C. They all decay at a different rate depending upon, are they in a starch matrix or a oil matrix or whatever. And so there is work in that. And similar work, less work in the pharmaceuticals. So the pharmaceuticals we need to take, antibiotics, for example, if you ever read your bottle, they're good for 1 year from original package or less.
Well, I know the Army has taken a look at some of that stuff to see whether or not the expiration date is real or not. And I guess they found that a lot of the pharmaceuticals can go at least a little while beyond their stated expiration date, with the exception of, like, acetaminophen or Tylenol. Tylenol, I guess, actually turns toxic.
Yeah, there is. HRP has, I believe it's HRP funded work on, they're doing a 3-year food storage study, and I think they're in year 2, and then they're also similarly doing at least 5 common classes of pharmaceuticals. I think one is painkillers. How does that compare to, how does its efficacy, hold up over time? And I think the initial results were encouraging, but there were a few substances that, did decrease significantly. And so part of it is what you're saying. Did it just decrease its efficacy and you could, quote, up the dose, or is it breaking down into something you need to avoid now?
And of course, none of those studies are looking at the effect of radiation on it, correct? Or at least not at this point.
I know that's on their radar. I don't know if they are exposing them to some beam time. That may be a separate study, not the just storage time study. I think there's maybe a dose effect, but I don't think anyone's studying a dose and time effect, although that's one of the, I think, maybe HRP objectives for Gateway, if they may be putting certain compounds or medications out there, so you are in that deep space, radiation environment, and you get the time on them. But the similar thing could be done on the moon.
Now, Gateway, Gateway's at, what should I say, that outpost that's in the near, for those that aren't aware, is the outpost that's in the near lunar orbit, and it's going to be unmanned for what, 9 to 10 months a year, but then when we have a guy on the moon or people on the moon, there'll be at least a couple of crew members hanging out there for an extended period of time while the other two descend, correct?
For early missions, I believe that's true. There's several variants where you can you might drop two people off. What it does is it allows you greater access to the latitudes of the moon. I'm not an orbital mechanics person, but somehow, it helps you get to the poles by stopping off at Gateway first.
Okay.
And so initially, only two people would go down to the surface, and then ultimately, we want all four people to go to the surface. There's also envisioned missions where crew would stay on the Gateway for I don't know how long, 60, 90 days to quote decondition, similar to a Mars transit, and then go to the lunar surface. Or two would, when you had four going down, you may have, actually, anyway, it's a detail, but so you could study the effects of our conditioning protocols on the astronauts' ability to get out of the vehicle and perform after they've been in microgravity for some period of time, because that deconditioning only starts to occur on the relatively short trip to the moon. But those are all just in the formulation phase,
Okay.
We got to get there first. We got to get there again first.
And you have to leave the moon to get back up into orbit when the sun sets.
Because it gets so cold down there?
So very, very cold.
Yeah. And so related to thermal, I guess, I think I may have had a bullet on it, is that, one of the discussions are to save power to sort of survive the night is if you could lower the temperature of the spacecraft when it's uncrewed, down into the 40 or 50 degrees Fahrenheit range to save power. And then you would similarly need to reduce the humidity. That's why maybe the relative humidity levels was sort of interesting, because if we, drop the temperature, how's that work with, on our microbial community? But so do we need to, really have desiccants, for example, beyond what we typically do for humidity control, which is heat exchangers, if we go dormant?
So this would be taking it well below the freezing point, or just above the freezing point?
Just above the freezing point. But we need to keep it a certain degree above the air temperature above it, because there's always cold points on the spacecraft, and we wouldn't want moisture to condense or freeze on the cold spots of the interior of the spacecraft.
Do they have issues with regards to I want to say I heard rumors that the plan was not to maintain a certain pressure in terms of the cabin atmosphere, or for that matter, even a certain composition of the cabin atmosphere during the unmanned portions, correct?
I've heard those discussed as topics. I don't know how, certainly they're seriously discussed. I don't know how strongly they're being considered. I haven't been in those types of mission sort of studies.
Presentations earlier today showed two different pressures and two different oxygen contents that they're studying.
For when it's crewed, we were talking about going down to 8.2 psia, and I think correspondingly 34% oxygen. Both of those, when you put the control bands on them, become a little more, extreme. And that's to reduce the pre-breathe time that a crew member has to do to get the dissolved nitrogen out of their bloodstream. And so I haven't heard any discussion of going lower than 8.2 in the rover or in the surface habitat. Certainly in the spacesuit, we go lower.
They're fairly comfortable with some of the technologies such as the TCCS and water processing assembly, just resizing it for a different cruise size then, or?
Ultimately, we want 4 people to go down to the cruise or to the surface. The initial Artemis missions are calling for only 2 people. And so when we talk about sizing the life support systems, we talk about sizing them for 4 people. The exception being the pressurized rover, I believe all the conversations there revolve around it being sized for 2 people. And so when you have 4 people on the surface, conceptually, you have 4 people that go down and they may be in the surface habitat for a short period of time, and then 2 people go out in the pressurized rover, and 2 would stay in the surface habitat and do some EVAs from the surface habitat.
Okay.
And then there's discussions, does the rover come back into the cruise swap? Or the rover has to come back for supplies and power typically.
I want to kind of get some input from, I don't want to lead the discussion or dominate the discussion. I guess, David Cullen, do you have anything you'd like to add or question? Zach, Hayden. Catherine Zagel. Okay, Catherine says no. Rajat Verma. Gisak Wang. Joel Kirkland, do you have anything you'd like to bring to the table?
Can you hear me?
Yes.
One thing that I've been thinking about a bit is transferring water and gases into a habitat.
Can you speak a little louder? Because I can barely hear you. I can hear you.
Is that any better?
Yes.
One thing we've been thinking about is transferring water and gases into a habitat, and how do you go about doing that? I think that's more of an engineering problem than a physical science problem, though.
Jim, I saw something that they were going to use something similar to the PWDs, portable water dispensers. Is that your understanding?
For dispensing water, yeah, but yeah, I debate too whether it's an engineering problem or is there some fluid physics or thermal aspects that we can use? Because like say you're moving waste we certainly know how to do it I'm just going to put it in a pressurized vehicle or vessel, put it in an airlock and take it over across the surface and into another, airlock. But we got to either thermally sink or bias that container that we're moving it. How long can it move for? The vehicles will be at different pressures likely. How's its interior change? As you're moving it, it's going to depend on where you are on the solar day. But it's a complicated problem, and so whether there's physics and maybe not biology there, but what physics or fluids could we do research on to make that problem easier?
So that
I don't have a good answer.
So, but it's not necessarily going to hook up a hose. You're going
That's
to
what
transfer.
some folks talk about, but my understanding, and maybe Ron has some perspective on umbilicals used on Apollo and earlier missions, is that's a lot of liquid volume. It depends on how much liquid volume you're trying to transfer. For example, gases, I could see it, but it just hooking up a hose isn't trivial, is my understanding.
On Apollo, all of that was contained inside the lunar module, the resources, water, oxygen, and such. And there was nothing outside with. You came back inside, and the astronauts spent time recharging their portable life support system with oxygen and water, and that was their housekeeping that they did inside the lunar module.
Joel, you say we can't hear you if you're saying something.
No, I was thinking.
You have any other questions?
Not at the moment. Thank you.
Alexander Zakharov, do you have anything you'd like to add or question?
Oh, thank you. I have a question.
Go ahead.
I have no question.
Oh, okay. I
Thank
didn't
you.
hear.
Thank you.
Peter Navala, do you have anything?
Nope, nothing for me. Thank you.
Brian Sperry, do you have anything? Brian, you're muted.
Yeah, I don't have anything. Thank you for inquiring.
Okay. Tyler, you got anything?
Yeah, John, one thing I'd like to bring up is that, at least personally, one thing I've been kind of struggling with all the move to, go back to the moon and design these new lunar experiments is how can we design something that might test one small fluidic science experiment? How can we design like a lunar technology demo just to study that, which is pretty easy on the ISS. But when we go to lunar, you've got to worry about thermal and radiation and all these other impacts that I think kind of limits our ability to do those smaller one-off experiments. Is the trend to go for like a bigger facility that'll allow multiple researchers or multiple areas of expertise to be tested on the moon, or do you think, well, we need to wait until kind of the initial lunar landing and the technology has been figured out to start developing these smaller science experiments? Or I'm just kind of unsure, like what to propose as far as new research and how we can get over that hump.
The smaller experiments might be better pursued on the CLIPS program, the smaller landers, which are totally robotic.
Right, I've seen a few of those, and I think there's one I know of that dealt with some of the solar panels and dust layers forming on them and the deposition, and that was a great experiment. It wasn't really with our group, but that's one I'm familiar with. But yeah, that's definitely one area I've heard of. Thanks. Ron, did you
Yes.
have something?
Yeah, so far, I think the solicitation that Tyler and I have seen has basically been somewhat limited in terms of power and data that we can get, as well as the payload mass. And I guess I'm wondering, is the plan to have a more expanded or a more extensive capability later on in the future in terms of unmanned landers, or is the plan to do, say, fluid experiments at some point on manned missions to the moon? Here's a new perspective. Michael Evans, do you have anything to add?
No, not at this point. Sorry, I'm trying to catch up on what you guys were talking about.
Well, I think most of our discussion happened the first hour. Lisa or Kevin, do you have anything to add?
No, not right now. I've just joined to listen in.
Yeah, likewise. It's been a good conversation.
And I can't, I want to say, let me pull this name over. I can't say this person's name, so and I don't want to botcher it. But do you have anything to add? All right, I guess, do we want to kind of call it quits for the day?
This is Ron. I'll just make a final comment that as I look back, I'm amazed that we did all that we could do on the Apollo program, getting those 12 astronauts up there onto the moon. Should have been 14, but you've got lots of challenges you've highlighted here. They've been highlighted for you here today, and I think they're worthy of discussion.
Yeah, yes, the plan forward is for us to basically, Tyler and myself as the note taker, we're supposed to do a write-up and submit it for the actual workshop report. And then I don't know if it's Kevin and Lisa will be responsible for the overall report, or if it'll be someone like Fran Chiaramonte. But that's the overall plan, is for us, for all these sub-sessions to get together, write an individual report about what was discussed, the challenges, and then how to address them. So, as well as any nifty little issues that need to be that we talked about. So.
And then one other thing also is that the Lunar Surface Sciences workshops are required to also take the reports and actually release them for public review and comment. So you will all be able to see what's written up in the finals, and I'll actually recommend or add things to it. So if you do come up with things after the fact, you can also go ahead and still add some information as well. But so that's something to look forward to as well. It's not going to just go, just be a report and stay internal, but it will come out to the public for comment and review.
And if you got anything else to add, feel free to shoot Tyler and myself an email, and we can easily incorporate that before the release of the report. And our email addresses were actually listed on the front. slide. John B. McQuillan at NASA.gov and Tyler R. Hatch at NASA.gov. All right.
And John, these sessions are recorded in the chat as well, in case people go back and watch them and do have any further comments or think of any new ideas based on the discussion.
Okay. All right. Well, we'll see you tomorrow at 10 o'clock. Look forward to hearing Harrison Schmidt's talk. Thank you all for participating.